All right, hello to all of my favorite eighth graders in the entire world. Today we're starting section 9.3, and we're talking about something called a two-way table. So here's just sort of an example. I just want you to observe this two-way table and see what you notice before we go into sort of the academic language behind it. So let's say you look at the title, so that I know that this is talking about all of my t-shirt sizes. I have small, medium, large, XL, double XL, and look at how many different colors there are. So what is this telling you? This is telling you that there's multiple colors that I could get in multiple sizes. This is what a two-way table is. I could get this color, this category. I could get this category in many different t-shirt categories. So all of these colors have multiple, there's sort of these two ways, a color and a shirt size that I could get for this. Now, let's say that these numbers right here are going to represent how many I have. So this is telling me for the blue and white color, I have 5 smalls, I have 4 mediums, I have 1 large, blah, 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 blah. And then this category right here, I just want you to kind of observe, what do you think would go here? Well, this would be the total of blue and white colors that I would get. So here's sort of all of the category totals. This is how a total of blue and gold people ordered. This is the total of red and white people ordered. And if I look down here, what do you think these totals would be? What do you think these totals are representing? Oh, well, these totals, this total is going to represent how many smalls did I have order completely, how many mediums did I have ordered in total. And so it really gives you a lot of information. And then what do you think the 65 represents? Well, the 65, this represents exactly how many total of these t-shirt sizes, or I'm sorry, of these t-shirts were ordered in general. How many of these t-shirts were ordered? Not talking about color or size, but just t-shirts in general. So we can get a lot from two-way tables. So I want to, let's see if we can minimize this and delete. All right, I want to get into our notes for today, so you guys should have this blank copy filled out, and let's get after it. So go ahead and you can fill in along with me. So this is section 9.3, talking about a two-way table. And so a two-way table, it displays two, shocker, categories. So in that previous example, we had size and color. So two categories of data collected from, and this is going to be the same source. So we're talking about the same source of collection. So a two-way table, it displays two different categories of data collected from the same source. Now, let's say that you randomly survey students in your school. And this would be actually very interesting to do for our class. But let's say you randomly survey students in your school about their grades on the last test and whether they studied for the test. So the two-way table here is going to show the results. And each entry in this table, so 21, 2, 1, 6, this is something that is called a joint frequency. A joint frequency. And if you just think about what that even means. A joint frequency, well, I'm joining together the frequency of people who studied and passed. So that would be 21. So people who studied, 21 of those people passed. People who did not study, only 2 of those people passed. So I can kind of conclude, obviously, if you study, you have a greater chance of passing. People who studied and failed was only 1. People who did not study and failed was 6. All right, so this is what we would call a joint frequency, is this 21 is joining together people who passed and studied. This 2 is joining together who passed and did not study. And then 1 and 6 are also these joint frequencies, So, an example, how can I read a two-way table? So, this is a question that you might be asked. How many of the students in the survey above studied for the test and passed? So I want to say how many of the students, I'm looking at the category of study, studied, and passed. So studied and passed, that answer would be 21. 21 students studied and passed. Well, what about a marginal frequency? What do you think this might mean? A marginal frequency. And I'm going to try to add in here. So a marginal frequency is, to give you a hint, these are called margins. Any of these, think of sort of like columns and rows. Is I have this margin of people who studied and this margin of people who did not study. Well, I also have this margin of people who passed and a margin of people who failed. So kind of like we talked about with the totals of the jersey sizes or the t-shirt sizes and colors, you can have these different margins. And a margin is defined, let's see if I can get my little text box here. So is basically, so the sums of the rows and columns in a two-way table is called a marginal frequency. So I want to add up the rows and the columns, so my rows and my columns in this two-way table. So for example 2, if I wanted to find the marginal frequencies, this is what it would look like. Ooh, let's move this up here. Oh boy. No, it's not letting me move it. Okay, there we go. And here's the point. I'm going to shout out a student for your warm-up. So I'm shouting out Gianna Scott. So your warm-up question is to say which student I shout out. This is your warm-up question, is Gianna Scott. All right, and so let's find, so example 2, I want to find my marginal frequencies. So here I'm just given my two-way table, but to find my marginal frequencies, I want to extend this out. So I'm going to extend this out in both ways. All of these lines I'm going to make a little bit longer. Let's do this. And then same thing that I did here, I'm just extending these out. So now I have a bunch of these different sort of categories that are going to go in here. Now here I want to say that this is going to be my total. Ooh, I don't want this. Hold on. So here's my total. And then here I'm also going to get a total of values going across. And now let's get my marginal frequencies. So one marginal frequency are going to be, it's the category of people who studied. This is the category, the marginal frequency of people who studied. 21 plus 1 is 22. So my marginal frequency here is that 22 total people studied. People that did not study, 2 plus 6 is 8. So people who did not study was a total of 8. So even right here, I could say how many total people were in the class. Oh, there would be 30. So my total and my total for studying and passing and failing, this is going to be 30 students. Now, what about if I wanted to look at the students? Well, what amount of students passed overall? Well, I can look here and find this marginal frequency, and I'm going to add 21 and 2 together, 21 and 2, which is 23. So I could, if I'm looking here, say that 23 people passed, and how many failed? I would add up together 1 plus 6. This would be 7. Oh, and notice how 23 people passed, 7 people failed. Together, 23 plus 7 equals 30. So these are all of my marginal frequencies. 23, 7. I'm going to circle all of my marginal frequencies. 30 is a marginal frequency. That's your kind of totals combined. So I'd say anything circled is my marginal frequency. And then basically you'll just be asked questions from here. So this is really all your notes is for today, is can you add up all your data? And then if I were to say, oh, how many kids passed? Or what was the ratio of kids from passed to fail? So from passed to fail, I could say, well, 32 kids passed and 7 failed. So that's a ratio of passed to fail. So it'll really just be analyzing this, answering the questions, and yeah, we'll dive a little bit deeper into this section tomorrow, but this is sort of an overview um, of this chapter.